Hey physics fans, today we're going to be looking at text problem 7-31 in volume 2 of your OpenStax textbook. Now in this problem we're asking for the work required to assemble a hydrogen atom. So after we've read the problem, we know that this is a problem dealing with work and it's a problem dealing with potential energy, and we'll get to why that is later. So our task is the work required to assemble our hydrogen atom. Our physics, well first we know that there's a relationship between work and some change in potential energy of the system. Second, we know the equation for potential energy due to some electrostatic force. All right, so we're looking for a relationship between our work and the electric potential energy. In drawing the problem, we have our proton, and then we bring in an electron from some infinite distance away to a fixed position given in the problem. So for our givens, we're given that fixed position, and since we're working with an electrostatic problem, and we have Coulomb's constant, and we have a few different charges, we can figure out what the charges of our protons and electrons are on the back of your reference card. And we know that Coulomb's constant is also on the back of your reference card. Now we're going to assume that the work that they're asking us to solve is the work done by the Coulomb force between the two particles, and not the work that you are pushing on the particle to get it into the system. In solving this problem, we start out with our relationship between the work due to a conservative force and a change in potential energy. Our change in potential energy is the final minus the initial potential energy, which initially, since it's an infinite distance away, that potential energy goes to 0. After substituting all of our known quantities on the back of the reference card, we can then calculate what the work is due to our conservative force. And the work is 4.36 times 10 to the negative 18 joules. Let's check our answer. The units are in joules, and work is a type of energy, so that makes sense. Least number of significant figures is 3, and it seems reasonable that we're getting a small but positive work, because our positive proton and our negative electron are attracting each other, so the force and the displacement that we're bringing our electron in are in the same direction. So a positive work seems reasonable. Thanks physics fans, and we'll see you next time.